Greetings, Calc 2 students. This video is for section 11.6, and this section talks about absolute convergence, the ratio test, and the root test. For this particular video, we're going to talk specifically about the root test. So remember, we've been dealing with the situation where we have an a sub n, and we're subbing that up from n equals 1 to infinity. So that's an a1 plus an a2 plus an a3 plus ... off till n reaches infinity. So for the root test, what we're going to do is take that a sub n, apply an absolute value, and then apply the nth root of that, and then the limit as n approaches infinity. And then the root test will have either one of three situations. The first situation that we want to think about is what happens if L is less than 1. Then a sub n is absolutely convergent. And remember, if a sub n is absolutely convergent, that means that a sub n itself, that series, is convergent. So something's absolutely convergent, it's also convergent. The second thing that we could find is we have the situation where the limit as n approaches infinity, absolute value of a sub n, take the root, is equal to L, and that's bigger than 1, or it's equal to infinity. So if that's the case, then we're dealing with a sub n is divergent. And finally, case number 3 is kind of the worst case. What happens if we apply that limit as n approaches infinity of the root, the nth root of the absolute value of a sub n, and it's equal to 1, then we don't know anything. And I think that's the worst case because we did all that work and we didn't accomplish anything. So let's look at an example. Determine if the summation of n equals 1 to infinity of minus 2 to the n divided by n raised to the n is convergent or divergent. So I mentioned before that usually my go-to test, if I'm not being told specifically what to do, is the ratio test. Now, I use the ratio test first, usually, unless I've been told to do something else, or it's easier for me to see that some other test might be better. So what I look for is if I have the case where I have an a over b raised to the n, if that's the form I'm looking at, then I think don't use the ratio test, use the root test. And the reason I think that is I'm going to apply the nth root of the absolute value of a over b raised to the n. Then the idea is that I'm wanting this to simplify to just the a over b. Okay, that's the sort of idea I'm thinking about. So often I abandon the ratio test if I can see right away that I'm in this situation of a over b raised to the n, and then I'm going to use the root test. So in this situation, I have a sub n, and that's equal to minus 2 raised to the n over n to the n. And sure enough, I can write that as minus 2 over n, the whole thing raised to the n. So now I'm thinking I'm sort of in this a over b raised to the n situation, so I'm going to use the root test. And what's important to see here is if I have the absolute value of a sub n, that's equal to minus 2 divided by n raised to the n, take its absolute value. And that's the same thing as 2 over n raised to the n. So then when I apply my limit test, I have the limit as n approaches infinity of minus 2 over n raised to the n, take the absolute value, and then take the nth root. And that's the same thing then as the limit as n approaches infinity of the nth root of 2 over n raised to the n. And that then is the same thing as the limit as n approaches infinity of 2 over n, which of course then is equal to 0. And so 0 is less than 1. And so from our root test, if the limit is less than 1, we say that a sub n is convergent. So a sub n is convergent.